What we're trying to get through today is why TypeScript. There's a bazillion new technologies out there, and it's your job to assess them and decide if they're for you or not. And if you take away nothing else, I want you to understand why TypeScript is worth your time, why you should take the time to try it out and give it a shot. I'm also going to show you how to get started fast in any JavaScript project you have. Then finally, I'm going to walk through a couple things that are new in TypeScript in the last year or so. So why TypeScript? For us, it's very simple. We believe that developers should be able to focus on creating amazing things. And creating is bolded here because that's why we're all here in the first place, right? To create new experiences, to create new workflows, to make people's lives better. I don't think anyone's here because they're passionate about debugging or they're passionate about Scrum. If you are, all the power to you, but I think we're all here to build cool stuff. But that's not how we actually spend most of our time. If you look at the day of a developer, you can really bucket any activity into 3 different categories. You have understanding code, which is reading existing source code, following the trace, looking up documentation. You have maintaining code, which is preparing for new features and fixing bugs and refactoring code. And then after you pay all of that tax, then and only then can you actually start to write new code to go build that experience you set out to build in the first place. And with JavaScript, we found that this is particularly difficult. Have any of y'all heard of Project Monaco? A few? Monaco is the predecessor to VS Code. It started with the bold ambition of let's go build a fully featured editor and put it in a browser so that you can edit code directly from your browser anywhere without an environment. And so, of course, this was all JavaScript, and it got to 300,000–400,000 lines of code, and it started getting difficult. And then it hit 600,000–700,000 lines of code, and it got almost impossible. The code base was effectively read-only. And we actually measured what the breakdown of our time was. And we found that over 95% of our time was just understanding and maintaining the existing code base, those 700,000 lines of JavaScript. And only 5%, which is 2 hours in a 40-hour week, were actually building that new editing experience in a browser. And so we took a step back and we said, what if? What if instead of building a new framework like everyone else does, that we build tools that shave off time from understanding and maintenance, that help you be more productive when you're paying all that tax, so that all of that free time that you get in return can be funneled into the creation. And it was chasing that idea that we created TypeScript. Now, TypeScript, by definition, is an optionally typed superset of JavaScript that compiles back to JavaScript. But I've always been more of a show than tell kind of guy, so let me just show you what I mean. So I'm going to open up a simple file here. It's just JavaScript. We've got functions, we've got objects, we've got if statements. Nothing special going on here. This is just plain ES5 JavaScript. And to get started with TypeScript, all I'm going to do is at the top of this file, add @tscheck. And what this is going to do is it's going to signal to VS Code and the TypeScript compiler that's running in VS Code that, hey, I know this is a JavaScript file. I know it's not TypeScript, but I want you to type check it as if it were a TypeScript file. And so this is an easy way of taking any existing JavaScript, because any existing JavaScript is TypeScript, and just running the checker, just to see what comes back. And so I'm going to run the checker on this file, and you can see I already have red squiggles. And so what's happening is TypeScript in the background is looking at all of the objects, all of the variables, all of the identifiers in your entire file, and it's trying to understand what all of the types are. Because while JavaScript is dynamically typed, you can change anything at any time for any reason, types do exist. And so there are places where there are certain expectations and contracts, and TypeScript's going to go look at all of those things. And it's going to tell you where things look fishy. So if we look at this first error, we can see that this argument of this type, which is this object literal here, is not assignable to a parameter of type property descriptor. And so what they're basically saying is, hey, there's a set of known properties that this function takes. Specifically, this parameter in this function takes. And you're not matching that. Something's off. And so we can actually look at that. Because this is TypeScript, I can go to definition on define function and look at the types that exist behind the scenes in JavaScript. If you look this up on MSDN or any other documentation for the JavaScript language, you could find all of this information. But we have it right here in the editor, because this is what TypeScript uses to build up its type information. And so here we see this parameter is of type property descriptor. If we look at that as well, we now have a property bag. And we can see that all of these are optional. But there's only 6 values that they actually expect. And we passed in read-only. And if we look back at this file, read-only is not one of the options expected. Writable is there, which is probably what we intended, but read-only is not. And so what actually happens at runtime? At runtime, your JavaScript engine will take this line of code, it will read the function, it will look at all the parameters, it will take in this property bag we have here, start trying to configure your function to behave however you expected it to, and it's going to see value, and it's going to consume that and do whatever this parameter does. It's going to see read-only, and it's going to say, hey, I didn't ask for a read-only, I don't want it. And it's just going to take it, throw it away, and pretend like nothing happened. It's not going to tell you about it, it's not going to raise a warning, it's just going to pretend like it was never there. And so now you have this function that's misbehaving because it's misconfigured. But you don't know that. And the only way for you to find that is hours and hours of painstaking debugging. TypeScript's going to go ahead and highlight this and say, hey, your types are off. Something's fishy here. You should probably check it out. And sure enough, we probably intended to put writable true instead of read-only false. A common mistake that I do all the time when I don't look up documentation, but it happens all the time. Let's look at another example. We have ship weight greater than 100, and TypeScript's telling us that the operator greater than cannot be applied to types, this function that returns a number and a number itself. And so if we look at this ship weight, we see, sure enough, it is a function that returns the parsed int of this text content. And so probably what we wanted to do was actually call this function. But this is a common mistake. You know, you're ripping along with IntelliSense, you start typing ship weight, you tab complete, and you move on. And without the call, you're comparing a function and a number. And what happens in JavaScript when you compare a function and a number? Does anyone know? It's false. Why is it false? I have absolutely no idea. No one would ever honestly want to compare a function and a number, but it is. Every single time this function runs, you're going to get false. And you're not going to get an error, you're not going to get anything, you're just going to have this if block, this logic is going to be behaving in a faulty manner, and you're not going to know why. And again, hours of debugging later, you will find this simple mistake. Because JavaScript doesn't love you. JavaScript doesn't care if you spend all day debugging and not writing code. TypeScript does, so TypeScript's going to highlight that and just point you in the right direction. So again, this is all JavaScript. We haven't done anything new here. We're still in a JS file. But TypeScript's already helping us be more productive. But that's not all TypeScript does. TypeScript doesn't just do type checking. Actually, first, let me show you one case where right out of the box, we can't do any inference. We need more help from the user. So when you take in a function in JavaScript and pass in parameters, you can pass in whatever you want. And TypeScript knows this. So if you just have a random parameter in a function, we're going to type this any. And what that says is, hey, you can put in any value on this thing. I'm not going to complain. You do you, but you're on your own. We can do better than that by telling the compiler exactly what we want. So here I just added a JS doc. You notice in VS Code, it'll scaffold it out for me. And I can now say, I want this to be a string or a string array. And TypeScript will go pull this type out of the JS doc comment and apply it to email address. And now you see it's no longer an any type, it's a string or a string array. And if I scroll down, we see we found another error. This one's fairly trivial. It's just a misspelling of trim to trin. But again, that's something that happens all the time. And JavaScript's not going to tell you that. You're not going to get that error until runtime when they tell you that, you know, function trin does not exist on object whatever. And now you have to trace your way all the way back. TypeScript will catch that sooner, and all because we gave it more type information. But we don't have to. Notice we have another function here with another address that's any. You only have to put in types where you want to, hence the optionally typed. And it's nice that you can add them in JS doc comments because you can gradually add these as you go, and there's no pressure to completely convert all your files at once. So this is a new thing we added recently called tscheck, or another config option we have in a tsconfig file is called check.js. It allows you to use JavaScript files as if they were TypeScript, and this is nice because you don't have to bother with the compiler. If you do want to bother with the compiler, you get some extra stuff, and let me show you what that is. So I'm going to go ahead and now convert this file actually from JS to TS. And you'll notice nothing changes, right? Because JavaScript is TypeScript. This is still all valid TypeScript. But now what I have to do is I also have to compile this file. It's also worth noting when you're in TypeScript, you don't have to use JS doc comments, you can do inline type annotation. So I can now say string or string array. Because this is valid TypeScript syntax, this would not be valid JavaScript syntax. And so when I now run the TypeScript compiler on foo_ts, it's going to take this TypeScript file, it's going to look for all of the non-JavaScript things, like this type annotation, and it's going to strip them out. And so if I pull this over here, you'll notice that our send updates is exactly the same minus the type annotation, and everything else is identical. The upside of running it through a compiler is TypeScript also does down-level transformation. And so for those of y'all who are familiar with ECMAScript 6 or 2015 or the latest version of JavaScript, you know that it brings a lot of new features. One of such is the class. Rather than a function prototype class, which was traditional in JavaScript, we now have true object-oriented looking classes. And what TypeScript will do is it will take that ES6 class and it will convert it back to a function prototype class for you. And why does this matter? This matters because the JavaScript language is evolving very quickly, but the browsers and the runtimes aren't necessarily keeping up. What this means is you can write this fancy new syntax, but it may or may not work at runtime depending on what browsers you're targeting. For example, if you're targeting IE 8 or 9 or 10, none of those support ES6 classes. And if you write this code, it will work in Edge and Chrome and Safari, but the moment someone opens it in IE 10, it's going to explode. And so what we typically do in JavaScript is we bring it down to the lowest common denominator. We say, OK, if I'm supporting an older browser, all of my code will be ES5 compatible. And the way we do that is by down-level compiling it. And TypeScript will do this for you. So what you just saw is the optionally typed superset of JavaScript. TypeScript is JavaScript. You don't have to change anything. All you have to do is add types if you want to. And when you do, TypeScript will help you find those little pesky errors and save you time so you can actually get to writing code. And then you also saw that it compiles back to plain JavaScript. And that's important for anyone who has to support older browsers or older runtimes. It can help you save a lot of time by using the latest and greatest features, but also supporting the lowest common denominator of JavaScript. And so what did we see? You can start using JavaScript today. Of course you can use JavaScript today. You can use TypeScript today, and it's super easy. All you have to do is add tscheck to any JavaScript file. It works great in VS Code, and I would recommend trying it in VS Code first. But you can do it in really any editor as long as you're using the TypeScript compiler. And you can start getting type checking in your JavaScript. You can start being more productive using the compiler to help you today. You can also use optional JS doc comments. If you already have JS doc comments with types, you'll get a lot for free. If you don't, you can add them at your leisure and start experimenting with types to see if you even like it. So you get it. You're like, cool, TypeScript is a type checker for JavaScript. But you know, I'm the best JavaScript developer who ever lived. I don't need help. I write perfect code. I never write bugs. If that's the case, it's probably true for you, but not your teammates. And there's actually a paper a while back that looked at a bunch of open source projects to see, do type systems really work? Like, what is the quantifiable amount of work you can save by using a type checker? And they found that as a bottom bar, that 15% of bugs that make it into production are detectable by type systems in JavaScript. That means take 15% of all the bugs your team produces and throw them away. That's time you can spend making progress and not maintaining your code base. And we think that's pretty cool. So what's new? We're going to shoot through as much of this as possible. We have three big things: non-nullable types, map types, and we'll probably skip map types and go to code actions or refactorings. But these are big features that everyone should be aware of, and they radically change how much TypeScript can do for you. Talking about nullable types real quick, when you think about JavaScript, you know, anything can be, any variable can be anything, so no one really keeps track of null and undefined and all of that. It just kind of happens. When you have a type checker, you start to care. You want to know what values can have null values and what can't have null values. And so traditionally, TypeScript has a nullable type system. And what that means is every single type could also contain the values null and undefined. What a non-nullable type system is you take away that null and undefined value and you put them in separate types. And what this does is it allows you to look at a type, and if you see it's a number, you know it's always going to be a number. You don't need to check to make sure that value will exist. TypeScript can do it for you. And then when you want to decide, OK, I need a nullable type now, you can combine them. And in TypeScript, we have this idea of a union type. And it takes two types, and it says, the values of this variable can be either a number or null. And so in this case, we can be a number or null, or a number, null, or undefined. And now we get back to that original nullable type we had. And so now let's jump real quick back to code, and I'll show you what this means. Let me switch that back to false. So by default in TypeScript, we use nullable types. And if we look at any set of code, all right, well, it's not going to update. By default, you have to turn on strict null checks, which enables non-nullable types. And by doing so, we get additional checking on what we already had. You didn't get a chance to see it, but this code normally checks out when strict null checks is off. There are no errors. As soon as we turn it on, we see that there are actually a lot of errors. And that's because nullability in JavaScript is pesky. And so let's look at some of these. Object is possibly undefined. So TypeScript's looking at this text, and it's saying, hey, it's a parameter. You said it's optional because there's a question mark. And it could be undefined. And so what I need to do is make sure that it exists before I do this, or else I will get that object is undefined error that everyone hates so much. And in doing so, that error goes away. Now I can look at number, and we say this function lacks an ending return statement. And by that, it's saying, hey, you've got this if block that surrounds your only return statement, and you need to drop that outside. Easy enough. We can now look at count, and it says count is used before it's being assigned. And if we look at count, sure enough, we define it, but we never declare it, or the other way around. And that's not 10, we want 0. And those errors go away. And now we have seemingly one more, and it'll say string or null is not assignable to string or undefined. And so here we're passing in null values into our what we asked for as a string array. And TypeScript's saying, no, you can't do that. And so I can say, but maybe I actually do want to do that. And now I'll just use that union type I showed you to say, yes, string or null values are allowed. And that has shown us one more error, that line is possibly undefined. And now that we allow null values, text can be null, which means line can be undefined, which means that now we have to check to make sure line exists. And now we can be certain that this code has no bugs. But you see how many errors exist with nullability in JavaScript. And in JavaScript, you would have sat there playing whack-a-mole for hours as you fixed one, reran the code, found another, fixed that, reran the code, found another, and you'd go on and on and on. We just fixed probably 6 bugs in a row. That's an afternoon of debugging. And TypeScript will save you from that. Let's go look at a control flow analysis example. Along with non-nullable types comes this cool thing called control flow analysis. And what it lets us do is look at the value of a variable as it evolves over time. We can basically compute every possible value of a variable at every single location during the execution of your code and tell you what the possible values are. And so here we have this weird thing that gives us an A, a B, a C, or a D. And if we look at X, sure enough, it can be a B, C, D, or an E. And now we have this kind of weird, convoluted section of logic. Right? And if you are working on this code and this is not yours, you have to go through and trace the flow and figure out, OK, what can X possibly be at this location? Well, if I start at the top, if it's an A, then sure enough, it's an A here. If I rename it to a B, then OK, sure, it can be a B here. If it's a B or a C, then that makes sense. But you get to the end, and it's like, OK, well, what is X here? Right? You have to sit there and pen and paper trace this entire thing, or maybe run the debugger, to see what this possibly can be. TypeScript's just going to tell you straight up, an E, a B, or a C. This saves you a massive amount of time when you're working in code bases that you're unfamiliar with. You can let the tools do the work. You can let the tools do the heavy lifting, and you can get to work fixing whatever you wanted to fix. Let's jump over to quick fixes. Here we have a class circle, and what I want to do is basically create this class and extend it from shape. And I'm going to show you some of the tools we've recently been building to just make you more efficient when you're writing code. And so first, I'm going to write extends shape. And you're going to see that this non-abstract class has not implemented an abstract member, and so I can just hit control dot, and it'll drop that getArea method in for me. As you can see, there's a getArea abstract function, and I need to implement it, and TypeScript's just going to do that for me straight up. I can now say, okay, well, I need a radius in here if I'm going to do an area. So I can say this.radius equals radius. And all of a sudden, I'm getting another quick fix that says, hey, you don't have a super call. All child classes need to have a super call first, so you need to add that. I've got another one here that's saying, you haven't declared this property in the class, so we need to go ahead and do that. And if I even want to, and I go ahead and add return this.radius times math.pi squared, I could even take this section of code and extract it to a separate function if it's complicated, right? And all of these things are little things, but they add up. They save you a lot of time over the course of your day-to-day programming. And we find that when we're writing code in advanced languages like C# and Java, these things are invaluable, all these quick fixes and refactorings. And so we started spending a lot of time in JavaScript and TypeScript implementing all these things. And we can do that because we have the type system knowledge in there to know, okay, this is a class, it's inheriting another class, and we can resolve all the modules and know the types, so this is the function you need. And that's pretty cool. And so all of these things we've added recently, and we're going to continue adding to make you more productive so you can spend more time creating the things you want to create. Let's see what we got. 5 minutes. Let's try to squeeze it in real quick. Map types. This is an example of something from the type system that we've recently changed. And it's a cool example of how the type system is evolving to cater to JavaScript patterns. So here we have, you can imagine we have a game with a master game state. It's a type. We have an initial state that we initialize. And we don't want these to be optional because if, for example, I try to create my game with no game name, that's a problem, right? And so I want TypeScript to tell me that's missing. But now let's say we have an update function, and we want to update the number of players remaining. I don't want to create an entire object that has a duplicate of all of that information when I'm only changing one property. And so here I'm getting an error in TypeScript saying, hey, well, you said this is a type of master game state, and you said that master game state has 3 properties, so what are you going to do about it? And so normally what you could do before map types is you could create a duplicate type, and we could call this partial game state. And then we can make all of these optional. And then we can make this a partial game state. And now this is all fine, right? But this is tedious. If you have to make a partial of every single type you have in your project, that's a pain. And then every time you go and make a change, I don't want this to be game name. I want it to be, best name. You have to make it in multiple places. And so we recently added something to make this easier called map types. And what map types do are they allow you to synthesize types in a very succinct way. And so we can say type, we'll call it mapped partial, and it'll take in some generic t equals, what is it? P of key of t in key of t. And that will map to the type of that property. And now we can say anything that comes into this mapped partial, we want to decorate with an optional. And so instead of having this new state, we can just call this a mapped partial of master game state. And what this does is it takes every property off of master game state, and it recreates a new type that's a partial of that, where that property is optional, and then it maintains the same type. But you can see how this simple little type system feature enables people to build much more intelligent types when you're working with frameworks. And so you don't actually have to use this yourself, but library authors can do a lot of cool things with this. And in fact, we don't even have to write this partial logic because it already exists. If I do just partial, and go to definition on that, you can see we've already added that type for you. It exists, and you can use that in any type you want. And so this is an example of how the type system is constantly evolving to meet the needs of JavaScript. TypeScript has never aimed to dictate how you write your JavaScript. TypeScript only aims to make it more productive, to make it easier for you to get done what you want to get done. And by evolving the type system as JavaScript evolves, we're able to do that. You also saw how you can finally tidy up those null and undefined errors that are scattered through your program with strict null checks. And I showed you a couple of the quick fixes and refactorings we've added recently. And there's an emphasis on building more of those productivity tools going forward. Because if you're going to add all these types to your project, you might as well get as much bang for your buck as possible. So in review, you saw how easy it is to get started with TypeScript. All you need to do, open up VS Code, slap tscheck at the top of any JavaScript file, and you can start playing with types. You saw how the language is rapidly evolving, but all of it is optional. We have new features all the time. We release TypeScript every 2 months, and there's constantly changing features. But you only have to use the ones you find valuable. It is strictly a productivity tool that you should use however you see fit. And most importantly, if you took nothing else away, you should know that TypeScript is built to let you focus on creation. It wants to make you more productive and save your time from debugging and maintaining so you can focus on creating. And that's all I got. It looks like I'm about out of time. We might have time for 1 or 2 questions if anyone has questions. Nope. Otherwise, thanks for sticking around. Again, I apologize so much for being late. And I'll be around for the next couple of hours if y'all have any specific questions. Thanks.